We have to prepare the shared numeric playground across thread before using atomics to prevent data corruption. We want to look at an example to demonstrate what happens when multiple background threads edit the exact same memory at the same time. So here I am inside my script tag, and first thing I want to do here is that I want to make a variable. Let me call the variable buffer. So it is going to be an empty variable. So now I want to use the conditional statement to check for the allocation of bytes of memory to my buffer. So how am I going to do that? I'm going to be making use of an if statement, if conditional statement to actually check. So I'm going to be making use of built-in methods and properties of the language. So window.cross-origin isolated. So this window.cross-origin isolated, what it's basically doing as it is that it's like a security protection for access into your system memory. So this new shared array buffer, the new shared array buffers parts that you're seeing, which we're about to write here, is what is going to be responsible for opening a multi-threaded accessible memory space instead of an isolated one. And like I said, that the cross-origin isolated is basically for security protection of access to the memory of your system. So what do I want to test? Well, I want to assign the results from this new shared buffer into my buffer frame that I've made here. But I'm not passing an encoded variable like this. Instead, I want to allocate 16 bytes of memory. So to allocate that 16 bytes of memory, I want to split it instead. And I'm just going to go and call another built-in property, 32 array. So I want to use this property to split it bytes per element. And for here, I can close my if statement and pass an else statement in case that condition is not met. So I need an else statement that's going to be responsible for handling whatever happens if that condition is not met. Array buffer. So I should tell that means 2 array per element. So now can come outside of my if conditional statement and make another variable. Let me call this variable. So the shared array is going to house the result of a new int32 array constructed. And then I'm going to pass in whatever the buffer result is inside it. Now, we're about to initialize our data slots in the memory. But before that, I quickly want to talk about this part that we just finished writing in our code. Now, I already talked about this part as being a security protection for access to your memory. And this part, which is a new shared array buffer, is responsible for creating an open multi-threaded accessible memory space in your memory, in your device or system memory. Now, what we have inside this, which is for 32 array dot bytes per element, is that this part dynamically calculates the exact mathematical space needed in order to hold our 32-bit integers. That is 4 times 4 bytes, which is going to give us 16 bytes. Now, in this next part, which is new in 32 array buffer, tries to slices that raw memory block into 4 readable numeric indexes, which means each block or each space is going to occupy 4 bytes of memory. So 4 bytes of memory. So that is how the system is going to allocate the memory space. And moving on from that, you can actually see that this code that we have here is just responsible for initializing our data. And now that I've gotten here, it is time for me to initialize, like I said, our data slots. Initializing data slots. And how do you do that? Well, just call your variable shared array, then assign it, use bracket notation to assign it a value of whatever you want. So this is going to be our data slot 1, our data slot 2, our data slot 3, as well as shared array. And lastly, I want to add one more. So now we have 4 data slots for our memory, and the value is not going to be 0. Actually, I'm going to just make them progressive, 30, 40. So now that we have done this, let's now go ahead to log out what we have and see the results for the screen. Document.get element by add table ID. Now this is going to be a shared array. Now, if you look at the screen right now, you can see the result of our shared array, 10, 20, 30, and 40. And so this is how the system is going to allocate memory based on the data slots that we have initialized in our code. Now, while this code initializes the data, if the background worker starts changing this slot simultaneously, it will cause error with standard math. For example, if you try to have something like this, so you want to use PS. So this is going to cause error. So how you prevent that error is if you use atomic method to change them safely. So if your data is changing under the background, if a background worker starts changing the slot that has been allocated simultaneously, it can lead to error when you try to increment the memory space or allocation for your data slot. So in situations like that, you make use of atomic method to change them safely. And what do I mean by that? So the atomic method just be something like this. Atomics. So this is also a built-in method in JavaScript. So if you look at this, you can see atomics, then the shared array, and this my variable name is passed in, and I'm passing in a position 0 and 5. So this automatically add 5 to data slot 1. You can see my editor is even supporting me by writing a corresponding description for what this is doing in my code. So this is how you make use of atomics. But in situations where the background worker is not going to be changing your data simultaneously, you are fine with what you already have on the screen and initialize your data slot in this way.